So we're going to find, gradient is another word for slope. So we want to find the slope of the tangent to this equation at x equals minus 1. So first of all, this is really talking about the big idea of what calculus is. The derivative finds us the equation of all the tangents, of all the slopes at any point that we want. So if we can find dy dx, we'll have an equation for all the slopes. And then once we've found dy dx, we're going to be able to plug in x equals negative 1 and find the specific slope at that point. So starting off by finding the derivative, and because it's a quotient, we'll use the quotient rule. There's the top, there's the bottom. Keep the bottom the same. Multiply it by the derivative of the top. Keep the top the same. Multiply by the derivative of the bottom. All over the bottom squared. Again, to help you see the pattern. Hopefully the colors help you see what's happening over and over again with the different functions. So that is the equation of every single slope at every single x point. That gives us all the different slopes, all the different tangents, no matter where you are in the function. If we want to be specific, at x equals negative 1, what would that be? Well, dy dx, this is going to be 2 times 3 minus 1 times 2 all over 2 squared. And then when we plug that in, I'm going to get 6 minus 2 is 4 over 4. The slope just becomes 1. Now, if we want to find the equation of the tangent line at that point, right, a couple of things. So now we go to the anytime you want to find the equation of the line, there are two main things you need to know. One of them is the slope, which we figured out in the first part. We already know that the slope of our line is 1. But you also need to know at least one point on that graph. Now, what we do know, first of all, when I see x cubed over x squared plus 1, I don't have an image of a graph that comes to my mind right away. If I thought about it long enough, I might be able to get some idea of what it looks like. But an x cubed over x squared plus 1, for me right now, it could be anything. So I'm going to pretend it's I don't know, that's awful graph. Okay? And then let's have some sort of scale there. But that's really bad. Should probably go into the negatives down here somewhere. Oh, it should go through 0, 0. There. So there now we have a pretty good graph at this point. The idea being, and we'll go and look at the real graph and get a better idea. But the idea being, at x equals negative 1, you have a point. And we are saying that we know that the slope of this tangent line actually looks like it could be 1. So at that point, we know that the slope is 1. What do we know about the 1 point on our graph? We know that the x coordinate is negative 1. How would I find the y coordinate of that point? plug in minus 1 into the function. And we need to plug it into the original function because this point is on the original function. This is not a point on our derivative function. Plugging in minus 1 into our derivative function finds us the slope. To find that point on the original graph, we'd plug it into our original one. So when I plug in minus 1 on the top, minus 1 cubed is minus 1. On the bottom, I get 1 plus 1 is 2. So I would know that this point is negative 1, negative 1/2. So anytime you're finding an equation of a line, the two things that you need to know are slope and a point. And now we know what the only point that we do know on that tangent line would be negative 1,1/2. Now, taking that, we can now plug it into, if this is the formula of lines you remember the best, you can use that one. If you remember this one best, you can use that one. I'll do it both ways just to refresh your memory. With this one, you know the slope is 1. Since you know a point, when x is negative 1, y is 1/2, you can solve for b. Add 1 to both sides, and you get 3/2 equals b. Oh, it's a negative 1/2 here? Thank you. Did I? Up here too, did I? There. Oh, I did it good everywhere until here, eh? Lovely. So adding 1 to both sides will give you 1/2. That's better? Good. Yes. When I miss a negative, please tell me. And so we get 1/2, so we could write this as y equals, you don't have to write the 1 for the slope, just x plus 1/2. If you wrote the 1 in front of the x, it's not wrong. So that's how you would write it in that form. In the other one, you know the slope is 1. Plug in your x value. It's negative 1. Plug in your y value at negative 1/2. So you'd have y plus 1/2 equals x plus 1. Subtract 1/2 on both sides. And you would get the same answer either way. I'm going to pull up GeoGebra and actually see what this graph looks like. Maybe I'll go. So, how do I change that one? Man, I'm rusty with this. There we go. So what did we have as our function? We had x cubed over x squared plus 1, x to the power of 3, x to the power of 3, divide by x to the power of 2, plus 1. Oh, my graph was a little off. Now, if we take this point right here and bring it down to negative 1, right there's close. Oh. I had it. Okay, it's telling us that at that point, we've got negative 1, negative 0.5. And we've got our tangent line drawn there. It figures out that our y-intercept, this program I put in, so it would figure out our y-intercept at 0, 0.5, which we found before. And so our equation of our tangent line is y equals x plus 0.5. And if we wanted to see, okay, if we go back to here, remember we found our derivative, right? This is our derivative. If we were curious, what does this graph look like? Well, if I just keep dragging this point all over the place, woo, that's a pretty looking graph. Kind of looks like a speed bump. Or a really nasty pimple under someone's arm if they're holding their arm out. I shouldn't, oh, and it's super. Okay, stop.